Machine learning teaches a computer how to perform a task without explicitly programming it to perform that task. Instead, we feed data into an algorithm, allowing it to gradually improve outcomes through experience, similar to how organic life learns. Welcome to Machine Learning for Engineers. As engineers, you've mastered solving real-world problems with precision and creativity. Now imagine taking that expertise even further, anticipating issues before they occur, streamlining your processes with minimal effort, and proactively responding to even the most unpredictable challenges. That's the transformative power of machine learning. By analyzing vast amounts of data and uncovering hidden patterns, ML enables you to forecast potential problems, optimize operations in real time, and make informed decisions. What if you could predict exactly when a component would fail long before it actually happens? Predictive maintenance uses sensor data to anticipate failures before they occur. Imagine scattered blue points on a graph representing real-time sensor readings. Machine learning transforms this seemingly random data into clear prediction curves, revealing the underlying health of a system. The model pinpoints 4 critical, high-risk zones. Highlighted in red, these are potential failure points identified by unusual sensor patterns. Yellow bands around the predictions represent confidence intervals. A dashed blue line projects future system performance, allowing you to pinpoint exactly when preventive action is needed. Today, predictive models are embedded in many of the products we use every day, and they perform 2 fundamental tasks. The first is classifying data. For example, is there another car on the road? Or does this patient have cancer? The second task is predicting future outcomes. For instance, will this stock price go up? Or which YouTube video do you want to watch next? The first step in building predictive models is acquiring and cleaning data. Lots and lots of data. The better your data represents the problem, the more accurate your results will be. Garbage in, garbage out. The data must contain meaningful signals to be valuable for predictions. Data scientists perform a crucial task called feature engineering, transforming raw data into features that better represent the underlying problem. The first step is to divide your data into 2 sets, often 80% training and 20% testing. The training data is fed into an algorithm to build a model. Then the testing data is used to validate the accuracy or error of the model. The steps we go through is often called the machine learning pipeline. Everything starts with data. Raw information flows into our training systems, where algorithms process patterns hidden within. The machine builds a mathematical model, represented by gears and formulas working in concert to capture relationships in the data. Finally, our AI assistant delivers meaningful predictions based on what it has learned. From raw numbers to actionable insights, this is the power of the modern machine learning pipeline, transforming how we solve complex problems across every engineering industry. Let's quickly cover how you'll be evaluated and what you can expect. Firstly, your skill set will progress through 6 mini projects. These projects are designed to help you consistently apply and reinforce your learning and will form the basis for the 20-minute oral examination. The exam is your chance to demonstrate your understanding and your ability to discuss the projects and course concepts confidently and accurately. Finally, let's briefly discuss why this course matters. In an era where technologies shape our existences, AI and ML rise above the rest. These cutting-edge technologies power intelligent systems, creating more advanced human-like machines and transforming a wealth of sectors, not least among them, engineering. The future is happening right now. You're preparing yourself to be part of a dynamic, tech-driven world. You'll also acquire fundamental programming skills, empowering you to create practical solutions and innovate effectively. The Python programming language is the industry standard when it comes to AI and machine learning, and you will be introduced to it and its many supporting frameworks that make the process approachable. Let's end this presentation with one of the most exciting applications of machine learning. The Lord of the Rings director, Peter Jackson, recently used ML technologies to enhance old footage and restore them for the digital age. In his 2021 documentary, The Beatles Get Back, Jackson and his team employed advanced ML techniques to isolate vocals, remove background noise, and upscale historical film footage to unprecedented clarity. These methods included deep neural networks trained for audio source separation, super resolution upscaling, and motion interpolation, allowing decades-old recordings to appear crisp and immersive as if they were filmed today. Enjoy the next 2 minutes, and I'll see you after for final comments.
This documentary, we were limited to the film that was shot for us, 50 years ago.
In 1969, a film stock was quite chunky, grainy, desaturated look to it. One of the purposes was to try to restore it, sort of making it look as natural as possible.
We had to look at each shot. Is it a close-up? Is it a wide shot? What sort of colours are in it? How grainy is it?
Suddenly, the colours were just unbelievable. People say, so how did you do all those colours? And I'm saying, well, we didn't do the colours, they were there.
I think we could have better mics.
We could have better mics, too.
To me, the sound restoration is the most exciting thing.
We get too excited.
We made some huge breakthroughs in audio. We developed a machine learning system. We've taught what a guitar sounds like, what a bass sounds like, what a voice sounds like. In fact, we've taught the computer what John sounds like and what Paul sounds like.
Doing this thing so that there's no overdubs or you can't get out of it is much better, really.
So we can take these mono tracks and split off all the instruments. We can just hear the vocals, the guitars. You see Ringo thumping the drums in the background, and you don't hear the drums at all. That allows us to remix it really cleanly.
We suspect that sometimes if they wanted to have a little private conversation, they might just play their guitars a bit louder,
And tune up the amps quite
just
loud.
to drown out their little secret conversations.
Can you tune down your amps a little bit more than that?
What?
The conversation, it's just being drowned a little bit.
Oh, you recording our conversation?
They're not drowned out anymore, I'll tell you.
Okay.
So you have to remember the words, too.
I almost know them.
It's like you're sitting in a time machine. We've either gone back in time or they've come forward, and it looks like it was just shot yesterday. It's been unseen for half a century, and it's our responsibility to show people this is the raw, honest Beatles.
That was marvelous. Yes?
You know who it is?
Beatles.
Now that is some pretty cool stuff. Sign up for the Machine Learning for Engineers course at VIA University College and be part of the team that engineers the future.